Yesterday we talked about key features of graphs, and we talked about domain and range all week. So I wanted to talk to you some more about domain and range, x and y, and key features of some different graphs that are not necessarily linear. So here we have f of x, remember that is y, is equal to 1 over the quantity of x minus 2 squared. It doesn't matter that we don't know what kind of graph this is because it gives us a picture of it. And I want you to notice how this graph is different than the ones we looked at yesterday. So you'll notice that there are two lines on this graph that do not touch. And there's a reason they don't touch. And that actually has a name. So this line right here is called x equals 2. And this graph does not touch that. That is actually called an asymptote. A-S-Y-M-P-T-O-T-E. And an asymptote is a almost invisible, for lack of a better word. It can be a vertical, it can be a horizontal, it can even be a diagonal line. Diagonal line. We're going to worry about vertical and diagonal. We can also say horizontal. I didn't write that up here. That a graph approaches means it gets really, really close to it, but it's not actually going to reach it. So this graph will never be equal to 2 on a table if we made that. So we can look at our domain. Well, we've got arrows going both directions. So that means that our domain is going to just be what we talked about the other day, all real numbers. So that is our R with the double line. But you'll notice that our range, it gets really, really close to the x-axis. And that means that our range is going to have a lower value of 0. Here's y. And it's also going to be less than. Now this is almost exactly right, with the exception of the domain. Look, I put all real numbers, but what did we say about this asymptote? So all real numbers, comma, x cannot be 2. So you have to make sure that you keep that in mind when we have an asymptote. We can also look at all of the different features that we talked about yesterday and see them on this graph. We have a Y-intercept, and we can kind of estimate that. It's really, really hard to see, but we know that it's about here. We can call our Y-intercept is approximately 0.25. You can also write 1/4. We do not have any maxes or mins. Because these are ending in arrows, they're going to keep going in both directions, so we have no maxes or mins. What I would like you to do is I would like you to pause the video and try these on A and then unpause it and you can check your work. So this is a parabola. Okay. This particular equation is what we call a quadratic, and we're going to talk about those in the spring. Quadratic. And you can see here, it does have a limit on our range, but our domain is going to keep going both directions. So our domain is all real numbers. There are no asymptotes on here. We do not have a lower y value for our range, but we have an upper y value of 9, so we can say y is less than or equal to 9 for our range. We can find our y-intercept, again, where it crosses the y-axis. It is written as a coordinate 0, 8. Do we have any minimums? Well, no. It keeps going down. So we don't have any minimums, but we do have a maximum, which remember, maximums are just the y value. So what is the highest y value? Well, we said it goes all the way up to 9. That does not have to be written as a coordinate point because it's just the y value. So hopefully you did okay on that one. The next one we're going to talk about is y equals 2x minus 1. Remember, based on our notation the other day, we said we can write f of x equals 2x minus 1. And this is just a linear graph. This is the kind of graph we're used to. Again, notice your arrows in both directions. It's going left and right and up and down. There are no boundaries, so there will be no windows to be drawn on this. So our domain, x is all real numbers, as well as our range. So you can have both be all real numbers, one be all real numbers. It just depends on your graph. What is the y-intercept? Where does it cross the y-axis? What is that b value? 0, -1. Plus, last year you learned y equals mx plus b, so you can see it in the equation as well. Do we have any mins or maxes? Well, no, we don't, because it's going in both directions and it just keeps going. Is this a function? Well, we've talked about what a function is. Yes, this is a function. How do you know? You have, it passes the vertical line test. You can give that as a reason. You can also say 1x per 1y. You can tell me no repeat x's. All of those are going to be valid reasons. The very last type of graph we're going to look at, this is an exponential graph. We're going to look at these in the spring as well. And this also has an asymptote. Way down here, it is a horizontal asymptote. This is actually y equals 0. It is also known as the x-axis. It's got arrows, so it's going to keep going. And it's going to get really, really, really close to this x-axis, but it's not going to touch it. So our domain for this particular graph is all real numbers, but our range, we have a lowest y value of 0. We have no upper y value, so we don't need to worry about that. 0 is less than y. We can also write y is less than 0. What is our y-intercept? Well, our y-intercept, if you'll recall, is going to be right there where it crosses the y-axis, and that is at 0, 1. Do we have any absolute mins? Does it stop? Well, I don't know. Does it? No, it doesn't. And it doesn't stop going up either, so this is an example of, again, no mins or maxes. We are going to work on this part 4 in class tomorrow because, as you can see, you need a graphing calculator. What I would like you to do before you come into class is I have this free graphing calculator app. I know you can do this on an iPhone, you can do this on an iPad. There is also an app for this on the Droid phones. So if you have permission from your parents, it is free. Free, free, free. And this is a very good tool that you can use at home when we have to graph. So, because you can't take my calculator. So if you have permission, you can download this on one of your devices. So when you're at home, we can do problems like number 4 here and graph them and see these. But as of right now, we're going to do these in class tomorrow.